Test. Test 1, 2. How about this? Can you hear me now? Sorry, I've been having to tear apart my computer and put it back together lately. Is that working? Yeah? Okay. Sorry. All my controls said that I was getting sound. But I think it's because this thing got plugged into a different port. Alright. That's good. Alright, so as I was saying, sorry about my green screen not being up. I woke up a little bit later today, got a little less done, forgot to pull it up, so I had to set it up before class began. I was up until like 3 or 4 in the morning doing all the grading and sending out, well, mostly sending out reminders to kids that, hey, semester's ending tomorrow, but we have another week to get stuff done. We can still do this. And it was a lot of work and really tiring. But I think it's working because I'm getting responses from kids. Today is our last quiz, really part 2 of our final quiz. We're reviewing today. It's an optional review. If you've got someone that, if you got a dip or something, right? Or if you know someone that had to dip out of this and wanted to see the review, or, you know, wanted to see any of the previous classes, head on up to the video tab, send them there, and watch the old videos. I'm doing reviews on any of the quizzes that you guys might need to retake. All this week and next week. You name the time, you name the place, 2 in the morning on a Saturday, I'll be there. Whatever you want. But anyway, let's get into this. All we're doing today is doing a little bit of basic trigonometry, right, with our 2 basic 90-degree triangles, the 45, 45, 90, and the 30, 60, 90. And then we're applying that to our stuff that we did a couple days ago on the quiz, our area formulas with apophthegms and such, right? So that is the deal. So starting out with this, what you want to do is you want to head on over to Google Classroom here. Go to classwork. Oh, wait, that's not your class. Period 5. Classwork. And then go down to the review guide. This is review guide for quiz 7 part 2. Click on this guy, and that's what we're working on today. Lots of room for activities. Don't be intimidated by the number of questions. Again, it's not an assignment. It's a review guide. Nothing's due. The only thing that I'm requiring for you to be able to pass is to complete all your quizzes with an above 65%. That's it. Homework and everything else is just if you want to boost your grade from last quarter, etc. All that. Answer keys here, but we're going to go over it today as many as we can. We'll probably get all of them done. And then we'll take our quiz tomorrow. Again, final grades get locked in. I believe Miss Bechtel is next Friday is the date. I know it's sometime next week. Might even be next Saturday or something like that. But anyway, you guys have time to get this stuff done. Please come see me. Send your friends if they're worried. Time is not up. So, without further ado, let's start on this guy. It says use the Pythagorean theorem, May 22nd. Let me see, May 22nd is, yeah, next Friday. Yep. It says use Pythagorean theorem to find the side lengths of a 45, 45, 90 triangle with a hypotenuse of 1. So this is our base 45, 45, 90. Yep, quiz 7 part 2. Yep. Part 1 was 2 days ago, which you can still turn in. So here's a rightish triangle. See if I can make this look a little bit better. There we go. So it said 45, 45, 90. So I'll draw in a little right angle. And then 45, 45, 90 means that these 2 angles, maybe I should do something other than orange. Orange looks so close to red on this. Make sure I'm as bright as I can be. Means that these 2 angles are the same, right? Because they're both 45. Now, technically, you wouldn't have to label this, because we know if both these angles are the same, and that's 90, they have to add up to 180, so they both will be 45. But if you want, you can label it 45 and 45. I just need to know that both those angles are congruent, at the very least, for this triangle. And then it said the hypotenuse is 1. Now, the hypotenuse is always across from the 90-degree angle. It's the biggest side. So hypotenuse here is 1. And it wants us to find the values of these 2 sides. Well, the beauty of the 45, 45, 90-degree triangle is that it's also an isosceles triangle, an isosceles right triangle, which means that 2 of the sides are the same. The sides across from the 45-degree angles will be the same. So we can call these both x. And so when we do Pythag, we take our two legs squared and summed, and that's going to equal our hypotenuse squared. So we can do x squared plus x squared equals 1 squared. And we can actually solve this problem because these x's are both the same number. We only have one variable here with one equation. We can solve that. I've got 2x squares in total, right? When I combine those, I get 2x squared equals 1. If I want to get x on its own, I can divide by 2 and get x squared equals 1/2. Well, I want to know what x is, right? These individual values. So what I do is I root both sides. When I root this side, I get x, right? The root of x squared is x, right? Roots and squares cancel. And then when I root this, I root both the top and the bottom. So I get the root of 1 over the root of 2. Now, the root of 1 is just 1, right? What number times itself gets me 1 is what this is asking. Well, 1 times itself gets me 1, so the root of 1 is 1. What number times itself gets me 2? Well, there isn't a number times itself gets you 2, because 1 times 1 is 1, 2 times 2 is 4, right? We're already too big. So what number times itself gets 2? Well, root 2 is the answer. Can't get any simpler than that. Now, because this is a fraction, we have to check, do we have a radical in the bottom? And if we do, it is simpler to get rid of that radical and have something on top instead. This will just make it easier, kind of like when you simplify fractions, like 6 over 8, we'd simplify to 3/4. Both are correct answers, but in order to do easier math, sometimes it's easier to multiply something by 3/4 than it is to multiply by 6/8 or add, right? So you need to be able to interchange these things. So we're going to practice that now and get rid of the radical in the denominator. We're going to de-radicalize the denominator, which is very antithetical to my political opinions. But my math opinions, I do think it's best to have the radical out of the bottom if we can. So what we're going to do is we're going to take that 1 over root 2, and we're going to multiply by the radical that's in the bottom. Well, root 2 is our radical, our root, our square root, right? So we're going to multiply by root 2 over root 2. Now, this won't change our answer, right? Because if you just got an answer and then doubled it, right, your answer would no longer be right. It'd be a different answer, right? But this is going to change our answer because what we're really multiplying by is 1. Because root 2 divided by root 2 is just 1, and multiplying by 1 doesn't change anything, right? Root 2 divided by root 2, well, anything divided by itself is 1. So we're taking this number times 1. So it won't change the number. It's just going to make it look different. That's what algebra is all about, is getting a different perspective. Well, 1 times root 2 is root 2, right? 1 times anything is the thing you're multiplying by, right? And we divide by root 2 times root 2. Well, that's a number times itself. A number times itself means that number squared, right? So one way you could write that is root 2 squared. That's kind of gross looking. Really what you'd want to write is root 2 over 2, because the root and the 2, or the root and the square, cancel, right? They undo each other, kind of like adding and subtracting undo each other. So both of these answers are correct. This one, you'll notice, the root 2 is in the top. It's in the numerator. We do radicalize the denominator. We get rid of the radical in the bottom, right? So this is our quote-unquote simplified answer. This is a number that's most of the time easier to work with if you need to do work after the problem, right? If I needed you to multiply by this by 2, it'd be very easy to do. What's root 2 over 2 times 2? Well, it'd just be root 2, right? Half of root 2 is what we have here. Double it, you get root 2, right? If I told you to multiply this by 2, you might not realize that the answer is just root 2, right? You'd be like 2 over root 2, and that's just weird looking, right? So this can be easier to work with. And so we say we leave this in simpler form. Do I care either way? Not necessarily. No, not necessarily. Both are valid answers. Just like 6/8 is the same as 3/4. Now, I think you know that most teachers do care if you simplify your fractions down, right? Same thing here. But they're both correct answers. So that's how we know that in our 45, 45, 90 triangle, both of these sides are going to be root 2 over 2 when the hypotenuse is 1. Now this is super useful because we can take this base triangle that has a hypotenuse of 1, and if I were to give you another triangle that had a hypotenuse of, I don't know, root 5, as long as it's also a 45, 45, 90, it's really easy to figure out this question. So what we do is we draw the same triangles we had before. It's a 45, 45, 90. And all 45, 45, 90s are going to behave the same way. Now this one, they said, has a hypotenuse of root 5. Well, this triangle is just a smaller version of this guy. I know he's bigger on the page because it's just a drawing, but this is actually bigger because root 5 is a bigger number than 1. So what did we do to the 1 to make it a root 5? Well, we multiplied by root 5, right? 1 times root 5 gets us here. So if we multiply these guys by root 5, we'll get the answers for this as well. So what I'm going to do is I'm going to take root 2 over 2, and I'm going to multiply that by root 5. And that'll give me the answers here and here. 1 times root 5 gets me this guy, so root 2 over 2 times root 5 should get me this guy. Right? We're just scaling it up. If this were a 6 here, right, then I'd multiply everything by 6. 1 times 6 gets me 6. Root 2 over 2 times 6 would get me the answer here. So this one's actually pretty easy. Roots you can multiply together. So that's root 2 times root 5. Well, that's just root 10. And then we have to divide by 2. Now notice that the 2 isn't a root. So we can't divide this and get root 5. We just have to leave it like that. That's as simple as we can get. So that's root 10 over 2. Why 2, Alex? So I've got you up to here, right? That this is root 2 over 2, and this is 1. To get from 1, which is our base triangle, to a bigger triangle that has root 5, right? It's the same kind of triangle. They're both 45, 45, 90s, right? That's a 1. To get to root 5, we multiplied by root 5, right? We times by root 5. So we're going to times these guys by root 5 to get to these guys. So that's what I did. I took root 2 over 2 and multiplied it by root 5, and I got root 10 over 2. Okay. If you want, you can refresh your stream. That might help with the delay. So we multiplied by root 5 because there's a root 5 here. Right? It's the same triangle, but one of the sides is times root 5 bigger. If we multiply 1 by root 5, we get here. So we're going to do that the same for the other sides. That's all. If this was a 6 here, we'd multiply everything by 6. That's why it's useful to know this triangle. Because if you know this one, you can just multiply to whatever you need to get a bigger triangle. So for instance, and I know there's a bit of a delay, so you might be missing what I'm saying here, and might get it before I get finished with this example. But if I had another 45, 45, 90 degree triangle, like this, I know that these two sides will be the same. I know they don't look the same. Drew pretty poorly. If I knew the hypotenuse was 7, well, then I know that this triangle is 7 times bigger than this one, right? Because that has a hypotenuse of 1. So it's the same triangle, just 7 times bigger. So what I would do is I'd multiply these guys by 7 as well. 1 times 7 gets me 7. So root 2 over 2 times 7 is going to get me my answer here. Well, 7 times root 2 over 2 is just 7 times root 2, which is 7 root 2. And then we divide by 2. Can't simplify that. If that was an 8 there, we could do 8 divided by 2 and get 4, but it's a 7, right? Can't simplify it any further. Can't divide the root 2 by 2 because that's a root and that's a regular number, right? So our answer would be 7 root 2 over 2. Now you'll notice this produces a pretty easy pattern, right? If this is 7, then this is 7 root 2 over 2. If this is 8, it'll be 8 root 2 over 2, which you'll need to simplify. If this is 10, then this will be 10 root 2 over 2. Right? That's the beauty of understanding this base triangle. That these are always root 2 over 2 and the hypotenuse is 1. That you can just multiply to get the other sides. Alex, give me some feedback. Are you with me? while I wait, I'll show another example. 45, 45, 90 triangle. If the hypotenuse were 10, then 1 times 10 gets me this. So this triangle's 10 times bigger than this one. So I've got 10 times root 2 over 2 for my sides. That can be simplified. 10 divided by 2 I can do, right? That's just 5 root 2. 10 divided by 2 is 5, times root 2 is root 2. Okay. Well, if you're with me now, this triangle's 7 times bigger than this one, right? Because that is a hypotenuse of 1, this has a hypotenuse of 7. They're the same kind of triangle, 45, 45, 90. So if that's 1 and that's 7, we multiply by 7 to get this triangle, right? It's 7 times bigger. So these sides will be 7 times bigger. So instead of root 2 over 2, they're going to be 7 times root 2 over 2, which we can't simplify. This one over here, same triangle. They're both 45, 45, 90. This is 10 times bigger than this guy, right? So the sides are going to be 10 times bigger. So 10 times root 2 over 2. Well, I can simplify that because 10 divided by 2 is 5. And 5 times root 2 is just 5 root 2. So that's what these sides would be. So if you know this basic triangle, right, you can figure out any other one I give you. Doesn't matter if it's got a root 5 next to it, right? We just multiply everything by root 5. 1 times root 5 gets me root 5, so I need to multiply these guys by root 5, right? Root 2 over 2 times root 5. Root 2 and root 5 makes root 10, because they're both roots. And then we're supposed to divide that by 2, so root 10 over 2. Sometimes, but the numbers would have to get really big. So, let's see if I can come up with a problem that might be like that. Let's see. Let's see. So, in general, Alex, let me explain it like this. I think this would be a better explanation. Here's our base triangle, yeah? If I know that this bigger triangle, or maybe even smaller triangle, has a certain hypotenuse, let's say it's, I don't know, 18, right? I multiply by 18 to get there. So our answer is going to be 18 times root 2 divided by 2. Well, that's 9 root 2. Because 18 divided by 2 is 9, times root 2 is 9 root 2. Now, you got to check sometimes to see if these need to simplify, but for the most part, that's going to be it. That's going to be it. Now, I might throw a problem at you that doesn't give you the hypotenuse, but instead gives you one of the sides. Maybe I tell you that this is 8, right? These are both 8. Well, 2 ways to solve this. You can either say, what times root 2 over 2 gets me 8? Right? Because that's what I did to get from here to here. Figure out what that number is, and then apply that to the 1, right? That'll be your number here. Or you could just do Pythag, right? 8 squared plus 8 squared equals whatever this is squared. You can figure it out that way. Now, you'll notice that this one, this 30, 60, 90, is not the same as a 45, 45. Good. It's a different kind of triangle. And it says hypotenuse of 1. Now, we learned, again, because this is a review, we learned that in a 30, 60, 90, doesn't matter which way you label it. Let's say this one's the 30-degree angle. Let's call this one the 60. Let's use pink. Okay. We learned that when the hypotenuse is 1, the opposite of 30, see how there's 30? If we go across from that, the opposite of 30, this side right here, is always going to be half. In other words, whatever this guy is, the opposite of 30 is half of that. Well, what's half of 1? It's half. So for instance, if I had another triangle that was a 30, 60, 90, and I told you the hypotenuse was 10, then the opposite of 30 would be half that, which is 5. Okay? That's nice. I like that. That's pretty easy, right? If it's root 8, well then it's root 8 over 2 over here, right? So, for 1, it's a half. That's easy. This is the only memorization you have to do. Opposite of 30 is un half. We didn't have time to get into why that is, but it is. It always is. Always is. Now, what's the opposite of 60? Well, you can have this memorized for this special right triangle, kind of like how over time you probably are going to remember root 2 over 2 goes with 1, right? When it's 45, 45, 90. Or you can do yeah, exactly. It's double the one side. It's double the 30 degree, right? That's another way to look at it. Now, the 60 is going to be a different length, right? For a 45, 45, the sides are the same because it's isosceles, right? Both angles are the same, so both sides are the same. But because the angles are different here, these sides are going to be different. Now, if you wanted to figure out what this is, maybe you forgot it, right? Maybe you don't have it memorized. Because you use this a lot, so you might memorize it on accident. But if you don't have this one memorized, all you have to know is that the opposite of 30 is always half the hypotenuse, right? And then this guy we can do p-thag for, right? We can solve that, right? A half squared is 1 squared, which is 1, over 2 squared, which is 4. So a quarter. 1 squared is 1. I subtract a quarter. How many quarters are in the number 1? How many quarters are in $1? 4 quarters, right? So I've got 4 quarters here, minus 1 quarter. 4 quarters minus 1 quarter is 3 quarters. And then I root both sides, and I get root 3 in the top, root 4 in the bottom. Right? I root everything. Well, root 3 is just root 3, right? What number times itself gets me 3? There isn't one. 1 times 1 is 1, 2 times 2 is 4, right? There's no number times itself gets you 3. But root 4, what number times itself gets you 4? Well, 1 times 1 gets 1, 2 times 2 gets 4, so 2 is the root of 4. So that's what that is, root 3 over 2. So this side is root 3 over 2. So 30 is always half the hypotenuse, and the other side, when the hypotenuse is 1, will be root 3 over 2. Another way to think of it is that this will always be half of the hypotenuse, and this will always be root 3 times whatever that is, because root 3 times a half is root 3 over 2. You can memorize that, you can figure it out that way, or you can just do p-thag when you forget it. I almost always do p-thag just to make sure I'm right. This one, I can do p-thag to figure it out if I'm stuck, because I know these are both the same, right? Root 2 over 2. This one, I just have to memorize the opposite of 30 is half, right? Half the hypotenuse. So for instance, on this guy right here, I know this guy is 5, right? So I know my answer down here is going to be 5 root 3. A half times root 3 gets me root 3 over 2. 5 times root 3 gets me 5 root 3. You could also do p-thag, right? Call this x, and you get the same answer, right? Alex, I see you have a question. I'll get it in just a second. You'd break that down and break that down, and what you would get is 5 root 3. Basic geo, yep. Oh, not Alex. You guys just have the same color on my screen. Brothers. Yep, geo's at 1. So you can either say opposite of 30 is always half, and opposite of 60 is that number times root 3, or you can do math to figure it out. Either way. But here's your base triangle, right? We got to know the base one. When this guy's 1, we get half, and we get root 3 over 2. When this guy's 1, we get root 2 over 2 for both. How are you feeling about this first page? Because that's going to be essential for going on for the rest of this. How are we feeling about that? Also, if you want to join me over on class voice chat, I'll be muted over there, but you can talk to me. 50% understanding. Not bad for your first go of it, right? Because you've been missing a lot of streams. The key takeaway is this, Alex. We have 2 special right triangles. Obviously, there are other versions of right triangles out there. But these 2 special ones are really nice and useful. You encounter them all the time. The 45, 45, 91, where if the hypotenuse is 1, the sides are root 2 over 2. We can prove that with Pythag. Or the 30, 60, 91, where if the hypotenuse is 1, we get a half here, right? Half of this guy. And then we get root 3 over 2. I memorized this one, that it's across from the 30. And I usually solve using Pythag to get this, but you can also just say it's this guy times root 3, right? If that were 10, this would be 10 root 3. If this is a half, it's root 3 over 2. And then these ones you can get using Pythag, or you can memorize them, root 2 over 2. I would learn how to do the Pythag, because I will probably ask you to do the Pythag for this one. Okay? Both are the same number, so we do x squared plus x squared equals 1 squared, and then we solve. Let's go to the next page. We're going to practice using these. It says find the missing side lengths. Leave your answers as radicals in simplest form. So hopefully by the end of this, Alex will be feeling closer to 100%. Now, this is the 45, 45, 90 triangle, right? These angles are both the same, so these sides are both the same. So if this is root 2, then B is going to be root 2. Now, what would A be? Well, a couple ways to think about this, Alex. One, oh boy. One, we can look at our base triangle. Oh, that's the wrong piece of paper. We can look at our base triangle. This is our 45, 45, 90. Root 2 over 2 gets us 1 for the hypotenuse, right? What is root 2 going to get? Well, what number do I multiply root 2 by, or sorry, root 2 over 2 by to get root 2? Well, that's half of root 2, right? And this is root 2. So this is twice as big as this, right? That's half of root 2. This is root 2. So this is going to be twice as big. So if that's 1, A will be 2. This is twice as big, right? Half of root 2 is what we're saying here, right? And that's regular root 2. So this triangle is twice as big. So if this is 1, that'll be 2. You could also do Pythag if you get lost, right? And do root 2 squared plus root 2 squared equals A squared. We don't know what A is, right? If you got lost, if you didn't know this, right? Root 2 squared is just 2. Root 2 squared is just 2. So 4 equals A squared. When we root both sides, A is going to be 2. So you can either use your triangle here, or you can use your knowledge of Pythag and that this is an isosceles triangle to solve. Either way, If you see the connection, it's easy to say, oh, it's twice as big, it's 2, right? If you don't, do Ptheg. Oh, poor mail carriers today, out walking in torrential rain. Your boy's got a bit of a headache right now, but it's going to be fine. It's going to be great. It's going to be great. So here's another 45, 45, 90 triangle, right? So that means both of these sides are the same. They're across from those angles, right? This is our hypotenuse because it's across from the 90. Here's our 90 degree. We go across from that angle, we get this side. So that's our hypotenuse. So if this side's 6, then we know n is also 6. Now, 2 ways to do this. We can ask ourselves, what times root 2 over 2 gets us 6? And that'll be what m is. Or we can just do Ptheg. I'm going to do Ptheg. I think that's going to be easier. Both these sides are 6, and our hypotenuse is m. So we have 6 squared plus 6 squared equals m squared. 36 and 36 is what we get. That's 72. The downside of doing this way is you're going to have to simplify. If we root both sides, we get the root of 72 equals m. Now we can break that down. 72 I can break down into 9 times 8. And 9 is just 3 times 3. And 8 is going to be 4 times 2. And 4 breaks down to 2 times 2. So m is also known as 3 times 3 times 2 times 2 times 2. Right? 72 is 3 times 3 times 2 times 2 times 2. 3 times 3 is 9. 2 times 2 times 2 is 8. Right? It's another way to write it. And you'll notice that since this is a square root, that's 3 squared. 3 squared rooted is just 3. So 1 3 gets out. Well, 2 times 2 is 2 squared. 2 squared rooted is just 2, so 1 2 gets out. Now notice this 2 doesn't have any 2's to pair up with, it's just regular 2, so it's left under the square root. So the simplified version of this is 6 root 2, because 3 times 2 is 6, and root 2 is left over. It's a little bit easier to understand 6 times root 2 than it is to say root 72. So we say m is 6 root 2. Either is the correct answer, but this is the simplified answer, kind of like when you simplify a fraction. How we feeling? Yeah? Again, if you don't like using the special triangles, you can always use Ptheg. Now notice these triangles here are 30, 60, 90 triangles. So this is the 60 degree angle, which means this angle down here is 30. So we're going to want to use this base triangle, right? Where 30 is always half the hypotenuse, and then we get the other one by Ptheg, or we say this guy times root 3. It's up to you. So remember our base triangle is, this will be a half when the hypotenuse is 1. And then this will be this guy times root 3. So root 3 over 2. So we've got 60 degrees is 5. We need to figure out x and y here. We need to figure out x and y. Now this is tough, right? Because you want to be able to take this guy and cut him in half and get this guy. It's like, oh man, that'd be nice, but I don't know that guy. And I want to be able to take this guy and times him by root 3 and get this guy, but I don't have that guy, right? But again, the connection here is that this is half, right, of 1. This guy, you times by root 3, and you get your answer, right? So this is half of it. And then this is times root 3. So y times root 3 should get us 5. Right? Whatever's here, when you times it by root 3, should get us 5. So now I'm going to solve. That's y times root 3. I get y equals 5 divided by root 3. Well, we want to deradicalize the denominator. So I'm going to multiply by root 3 in the top and the bottom to simplify our answer. We get 5 root 3 in the top. Root 3 times root 3 is root 3 squared, which is just 3. So that's going to be our y. So that's y. It's kind of gross looking, but that's it. Now, let's find that last side. Now remember, this is always half of whatever this side is. So the problem with this one is you can't do Pythag because we have 2 missing pieces, right? And they're not the same value. They're not both the same. Right? Here we knew both these sides were the same. Whoops. We knew both these sides are the same, so we could do Pythag very easily. Here you got to use your special right triangle. This is one of the harder ones. So remember, whatever this guy is, we times him by a half, and we get this guy. So we know what this guy is. He's 5 root 3 over 3, right? If I told you this was 5, x would be 10, right? Because 10 times a half is 5, right? Well, this guy's 5 root 3 over 3. And he's half as much as this guy, so we got to double that, right? X is going to be 2 times 5 root 3 over 3. Right? Twice as big. And it looks really complicated, but it's actually not. 2 times 5 is 10. 10 times root 3 is 10 root 3. And then we're supposed to divide that by 3, and that's as simple as it gets. Can't break down 3 anymore. 10 divided by 3 doesn't come out evenly. That's our x. That's probably the hardest one I can give you. So you need to know your triangle relationships, right? This guy is always half, right, of whatever this guy is. So times a half. And this guy, always times root 3. So whatever's here, we times by root 3 and we get that. If we want to work in reverse, right, we divide by root 3. Right? This guy times root 3 should get us 5. We divided by root 3. We got our answer, and I simplified it. Looks more gross, but it's actually easier to work with later. Because then when we want to double it, we just times it by 2. Right? We know this guy's 5 root 3 over 3 now. And so to work backwards, we times by 2. We just double it. 10 root 3 over 3. If you're feeling about 25 to 30% on that one, that's pretty good for your first go of it. 7 is a lot easier. So this is our 60 degree. This is our 30 degree. Remember, this is always half of this guy. Right? The hypotenuse is 2 root 3. There's our hypotenuse, across from the 90. And it's always twice as big as whatever this side is, right? Whatever this guy is, he's always twice as big as this guy. Right? There's a relationship there. We can, once we've got it, I'll show you what I mean by that. So we can go by half. Well, 2 root 3, what's half of that? If I have 2 root 3s, what's half of that? 1 root 3. Root 3, right? So we know that y, where did my purple pen go? It's going to be root 3, right? I'll write that over here so we can see that. Y is root 3. It's half that, right? Well, you can either do Pythag now, because you have root 3 squared plus we don't know squared equals this guy squared. Or you can look at your special right triangle, Alex. Right? This guy's always half of this guy. And this guy's always this guy times root 3. So whatever this guy is, we multiply by root 3 and we get this guy. And that's going to get us this guy. Well, Alex, what is root 3 times root 3? Well, root 3 times root 3 is just the same number times itself, so it's root 3 squared. What's root 3 squared? 3. So x is 3. For 6? Oh, so what you could do, Alex, is you could get y, right? This guy. And since now we know y and we know 5, we can put those in Pythag and solve for x. You can either do that, or you can just multiply by 2. If you know your right triangles, it makes it a lot easier, right? Because you know that these two are related by double and half, right? So if I know this guy over here, I just double it to get to this guy. But if you wanted to do Pythag, you could. You'd have to set it up like this. After you got this guy, right, you'd have to do this to get this guy. Then you'd say 5 root 3 over 3 squared plus 5 squared, right, because that's what they gave you, would equal x squared, this guy. And then you'd have to solve. This means times it by itself. So we get 25 times 3 divided by 9, right? 3 times 3 is 9. Root 3 times root 3 is 3. 25, 5 times 5 is 25. Um, 9 divided by 3, or 3 divided by 9, that's 1/3. So I could make that this. And then how many thirds? I need to get thirds here, so I'm going to multiply this by 3 and get 75 thirds. Right, because 75 divided by 3 is 25. Now I got common denominators, and I get 100 thirds. I root both sides, and I get 10 over root 3. And then I simplify, because I multiply this guy by root 3 over root 3. Up to you. That's 10 root 3. That becomes 3. Either way. If you know how to use your right triangles, it's actually easier to do it this way, right? Get your guy and then double it. This guy times root 3 will get me 5, so I do math and find it. And then I double it to get this guy. We can do some more examples of those at the end if you want. I think we'll have the... actually, we're kind of running out of time here. Move ahead just a little bit. We've got some more examples here that I want to get to if we can. But I will just... I'll just talk about this one real quick. This one right here. So for instance, just real quick, I'll talk about this and then we'll jump to the applying it with our polygons. I can stay a little later if you guys don't mind going into lunch. I know some of you guys are just tuning in for the first time in a while. So, this is our 30, right? And that's always half the hypotenuse, right? So our hypotenuse must be 5. Right? Because half of 5 is 5 halves. So, got that one. And if you want, you can do Pythag to solve for this next guy. But what I would do is I would say, look, I know this guy. You always times him by root 3, and that's what gets your 60 side. What's 5 over 2 times root 3? Well, it's going to be 5 times root 3, right? 5 times root 3 divided by 2. And that's as simple as it gets. You can do Pythag if you know two of the sides. So after I had these two, then I can do Pythag to figure that out, but I think it's probably easier just to know your right triangles. What's the right side? 5 root 2, 5. 5 root 3 over 2. Here, I'll zoom in. Right? This is always half of whatever this is. So 5 halves is half of 5, right? So that must be 5. And then this guy's always whatever this is times root 3. So 5 root 3 over 2. Okay. Let me see if I can fit it on the screen here, Alex. So our basic triangle is this. And we know that when the hypotenuse is 1, this guy's always half, right? 1 and a half, right? We cut this guy in half and we get our answer here, which in this case is just a half. Half of 1 is a half. So we times this by a half to get our answer. 1 times a half is a half. And then we times this by root 3 to get our answer. Root 3 times a half is root 3 divided by 2. So if this is 5, it's 5 times bigger, right? See how it's 5 times bigger? So we times 1 by 5 and get 5. We times a half by 5 and get 5 halves, just like they gave us. And we're going to times root 3 over 2 times 5, and we get this answer. But you got to know what this guy is first. And the way we figured that out is we said, what's half? What number do we take half of to get 5 halves, right? What times a half equals 5 halves? Well, 5 times a half equals 5 halves. If you don't know that, you can do x times 5 halves equals 5 halves. I'm sorry, times a half equals 5 halves, right? Something times a half should get 5 halves. And then we do math. Divide by a half, which is the same thing as multiplying by 2. And we get 5. You can do Pythag after you get that 5 and solve for this guy, or you can use your triangle here and know that, oh, look, 5 times bigger, 5 times bigger, 5 times bigger. Multiply by 5. Yeah, where are you at, Alex? Awesome. Nice job, team. Famous Bechtel. So, finding the area of each regular polygon. We know the formula is going to be the number of sides times the apothem times the side length over 2. And the way I remember this is I think that what we're really doing is we're going to break this shape down into a bunch of triangles. So I'm going to break this down into a triangle here, right? And you'll notice if I keep breaking down the shape, I'll have 1, 2, 3, 4, 5, 6 triangles, right? I'll have the same number of triangles as I have sides on my shape. 1, 2, 3, 4, 5, 6, right? If I break it down like that. So if I find the area of this big triangle and times it by 6, then I get the area of the whole shape, right? Well, the area of the big triangle is going to be this. The apothem times the side length divided by 2, right? Base times height divided by 2. Our base is the side length here, right? That's our side length, our base. And then our height for our triangle is this apothem. Remember, an apothem is anywhere from the center of a regular polygon to the edge of a regular polygon at 90 degrees. So this is our apothem. And they said the apothem, right, is, or were they referring to the side length? I think they're referring to the apothem. They're referring to the apothem because I drew in the side length. So the apothem is 4 root 3. So our height is 4 root 3. We have 6 sides. What we need to do is figure out the side length here. So here's what we're going to do. We're going to break this down into an even smaller triangle. I'm going to figure out what kind of triangle we're talking about here, because this is actually one of our special right triangles. So this triangle right here, this angle right here, all the way across, is going to be the same angle as the triangle that we'd make here's angle would be, and this angle, and this angle, and this angle, right? So we've had this guy, this guy, this guy, this guy, and this guy. Well, that's 360 degrees altogether, right? Makes a full circle. We have 1, 2, 3, 4, 5, 6 of them, right? The same number of sides, we have these internal angles. So that black angle right there all the way across, that's going to be 360 divided by 6. So that whole thing's 60. Because 360 divided by 6 is 60. Which means this little bit right here, just this little bit, that's going to be half that. That's 30. So we've got a 30, 60, 90 triangle, don't we? So we want to figure out what this guy is. Just this much. So then we can double it and get what S is, right? The whole side length here. So that's the game plan. So I figured out this was 60, this whole thing here, because 360 all around, and we've got 6 angles. So that's 60. And then we divide that in half and get 30. So this is a 30, 60, 90 right triangle, this part right here. So I'm going to draw that out. Just that triangle. So here is our triangle. We said that this was 30. We said that this was 60. And we said that this was 90. And they said the apothem, this side, right? If I go back to here, that is 4 root 3. Now, our base triangle, Alex, I'm going to draw it out next to it. Right, is when the hypotenuse is 1. We know this side is always half of that, so it's a half in this case. And this side is always root 3 times a half. Oh, hello. Right? So we times by a half to get here. And we times by root 3 to get here. So we got to work backwards. Right? Let's make this guy green, root 3. So we got to move backwards to figure out what this guy is. So instead of timesing by root 3, we're going to divide by root 3. So what's 4 root 3 divided by root 3? 4, right? So that guy's 4. And again, we're working backwards. Instead of timesing by a half to get here, we're going to multiply by 2 to work backwards, right? So this guy's going to be 8. Now, all we needed was this 4. Because all I care about is this little side right here. So this little bit is 4, which means this whole thing is double that, 8. So S is 8. So the side of our big triangle is 8. We have 6 of those, right? That's what N is. 1, 2, 3, 4, 5, 6. And our apothem, our height on that triangle, is 4 root 3. Alex, I'm going to pause for a second before we go any further. How does everybody feel about figuring out this triangle, right? We times by root 3 to get to here, so I'm going to divide by root 3 to get back. So I divided by root 3 and got 4. If I wanted to go further, right, instead of timesing by a half, I go backwards and I multiply by 2. It's 8. All I needed was that 4. So I could double it and get this side length 8, which is what I needed to do my formula. Nas divided by 2. Remember, this part right here is the area of that triangle, right? The height, A, the side, S, divided by 2. Base times height divided by 2, and then we times it by the number of triangles we need. We do math, we get 6 times 4 root 3 times S, which in this case we said was 8. I'm going to divide this guy by 2. That gets me 6 times 4, which is 24, root 3. 8 divided by 2 is 4. So 6 times 4 is 24, times root 3 is root 3. 8 divided by 2 is 4. And I get 24 times 4, which is going to be 96. That's as simple as it gets. We can't simplify that anymore. Root 3 doesn't break down. So that's the area of our polygon, which I believe was a hexagon. Now, I'll stay through lunch if you guys want to do some more examples. Or I can take a break. It's up to you. So if you want me to stick around and do some more, I will. Oh, no. Okay. Don't worry about this. If you're using a calculator, I know some of you will, then you can do that. I'll allow that because I know some of you guys are for home learning, right? So I forgot to mention that. Or you can do what I'm doing and just simplify to this. That's cool, Alex. Either or I'll accept. Either or. I'll accept exact or rounded to the nearest tenth. Either or. Having an exact answer is always better than rounding, but I'll accept either. I know some of you guys are going to be doing calculator stuff. I can't stop that. Should I stick around and do some more examples? I don't recognize anybody other than Miss Bechtel and Alex in chat that are from my class. So if Alex is good to go, and Miss Bechtel, if you feel like you're good to go, I think I'll do maybe like 1 or 2 more examples just so it's on the recording, and then I'll send an email to everybody. But I think that's all the students we have in chat today. Thursdays are optional, so I understand that, I suppose. All right, well, enjoy your lunch. I hope it's good stuff. I'm so sad that I'm in an apartment. I used to have this gigantic garden. It would have been great to do some gardening this year. Maybe I'll be moving to Morrison into a house and get a backyard garden again. I'm looking for a place, okay? Let me know if you know a guy. Anyway, I'm going to do a couple more examples. I'll finish this out, and then I'll post it. Okay, take off, guys. So here they give us the side length. You already have lettuce up. This Bechtel. Normally, I've got a whole array set up, and I'll let you go eat, but I've got a whole array set up, like a metal frame shelf, right, with a bunch of tiers on it. And I have grow lights set up. Do a little aquaponics. I used to have like a little salad bar that I could just go grab stuff from. Arugula, spinach, lettuce, basil. Use that all the time. And potatoes. Yeah, well, I would imagine you have potatoes. You grow those through the winter, right? Lucky you. I used to have gigantic raised beds, all kinds of stuff. I had to tear it all down when I moved here. But soon. But if you know someone who's selling a house, let me know, okay? Or renting. Preferably, I suppose. Your boy can't afford it. Oh, I would imagine so, yeah. Yeah, when I had my community garden in Lyle, I didn't have to worry about that as much because it was more city area. But yeah, I took up a bunch of plots and it was awesome. Getting them emails. Oops. That's not how that works, bud. How do people still not understand the retake system? It is literally like the last day of the semester. We've been doing this all year. Do the pizza party? What do you mean, do the pizza party? The pizza problem? Like, make it into a pizza? Is that what you're saying? This is once again a hexagon, so we have n sides. We need to find the area of this triangle. And multiply by 6. Oh, okay, I will. I can't do it right now. I gotta finish this up. Here's our apothem. Center to 90. Opposite side. Chairs are gonna sink into this. Pull that out way more. Alright, so we need to find this apothem. And the only way we can do that is if this is a special right triangle. Well, we know this is going to be a 30, 60, 90. Right, this is our 30-degree angle from before. And this is going to be 60. So we know that this side right here is going to be half of that. So this amount of this side is going to be 5 root 3. Half that. So our base triangle is, if this is 90, this is 60, this is 30. If the hypotenuse is 1, the opposite of 30 is one half, and this is root 3 times a half. So root 3 over 2. So what we need to figure out is this side right here. Well, remember, to get from here to here, we multiply by root 3. So if this is 5 root 3, we multiply by root 3 to get this guy. Well, that's 5 times root 3 times root 3, which is 5 times root 3 squared, which is 5 times 9, which is 45. So again, in slow-mo, 5 root 3 is what we had, right? And we're timesing that by root 3 to get to this side, right? Well, 5 root 3 times root 3 is just 5 times 9, or 5 times 3, because root 3 times root 3 is 3. And then 5 times 3 is going to be our answer, not 45. This is why I got to slow down. Root 3 times root 3 is 3. 5 times 3 is 15. So A should be 15. Somehow I can always tell when I'm wrong. All right. So now we just do math, and we get our answer. We multiply all of our numbers. Doesn't matter what order. We divide by 2. I'm going to divide the 6 by 2. Doesn't matter which one I do. That's 3. So I get 3 times 15 times 10, root 3. Well, 3 times 15 is 45. 45 times 10 is 450. Root 3. That's the area of our hexagon. Same thing here. N is 6 because we have 6 sides. This is a 30, 60, 90. We don't know either A or S. We do know that this is 9, this hypotenuse for this triangle, right? So our base triangle right? When this is 1, the opposite of 30 is a half. The opposite of 60 will be a half times root 3, so root 3 over 2. So if this is 9 times bigger than this triangle. So a half times 9 is going to get us 9 halves. That's how much this is right here. This much is 9 halves. And root 3 over 2 times 9 is 9 root 3 over 2. So this is 9 root 3 over 2. Now, the side length that we're interested in is the side length of the big triangle, right? So if half of it's 9 halves, the whole thing will be 9. 9 halves times 2 is 9. Then we do 6 times 9 times 9 root 3 over 2, all divided by 2. This might look intimidating, but it's not too bad. 6 divided by 2 is 3. 9 times 9 is 81. And then we times it by root 3 and divide by 2. That divide by 2, I'm just going to put down here. Doesn't matter. It's all multiplication division. Doesn't matter what order we do it in. So this became the 3. And then 9 times 9 is 81, root 3 over 2. 81 times 3. 80 times 3 is going to be 240. 3 times 1 is 3. So 243 is what we get. Root 3 over 2. Triangle. This is our apothem. Now, because this is a triangle, n is going to be the number of sides, which is 3. S is going to be this big side length right here. Well, we need to figure out what kind of special triangles are here. Well, this angle right here all the way across, that's one of 3 of these angles, right? 1, 2, 3. So 360 divided by 3, we're going to get 120. So if this whole thing's 120, then this much is 60. And this will be 30. One 120 makes 360. Divided by 2, we get 60 here. So that's a 60, 30, or 30, 60, 90 right triangle. Our base triangle looks like this. One. Opposite of the 30 is a half. Opposite of 60 is root 3 over 2. So if this guy is 9, right, that's across from the 30. It's 9 times bigger than this guy, right? I shouldn't say 9 times bigger. I should say this. I should say this guy across from the 30 is 9. This is a half. So what do I need to multiply a half by to get 9? Or in other words, we can think like this. This side is always half of the hypotenuse side. So this side right here is 18. Right? This is always half of this, right? That's the relationship here. So if that's 18, this would be 9. Just like if this is 1, this is a half, right? They're half of each other. And to figure out this bit right here, all I need to do is take this guy and multiply by root 3, right? So I take this guy and multiply by root 3, and I get 9 root 3. And the whole thing will be double that, 18 root 3. Right, the whole length there. 3 times 9 times 18 root 3 all over 2. Right, NAS over 2. 18 divided by 2 is 9. 9 times 9 is 81. 81 times 3 is 243, like we found out last time. Ooh. The area of this triangle is twice as big as the area of that hexagon, right? 243 root 3. That's half. That's all of it. So it's twice as big. Notice that the apothem here is the same length as the side here, which we call that a radius, more or less. Some interesting properties here. You can do a cool little drawing with that. Triangle wrapped around that. Now for a square, same dumb crap. Draw your apothem. Now, this whole angle here is going to be one of 4 different angles, right? 360 divided by 4 is 90, so this is a 90-degree angle right here. Half of that is 45. So it turns out this is a 45-degree angle, and that's a 45-degree angle. So this bit right here will be the same amount as this bit here, right? It's an isosceles right triangle. So A and half of our S will be the same number. Now remember in our base triangle for a 45, 45, 90, when the hypotenuse is 1, this is root 2 over 2. So if this is 10, that's 10 times bigger, right? So we do this guy times 10. 5 root 2. 10 divided by 2 is 5, times root 2 is 5 root 2. So the apothem is 5 root 2. This much is 5 root 2. I didn't write that correctly. 5 root 2. This guy. And this will be twice as big, so 10 root 2, right? We have 1, 2, 3, 4 sides, so n is 4. So we do 4 times 5 root 2 times 10 root 2, all divided by 2. I'm going to do 4 divided by 2. Doesn't matter which one you pick. You could have done 10 divided by 2 and get 2. So we've got 2 times 5, which is 10, times 10, which is 100. And then root 2 times root 2, which is 4. Right? These guys, root 2 times root 2 makes 4. So we get 400 is the area of the square. This one, they give us the full side length. We know n is 6 because it's a hexagon. We just have to find that apothem, and then we're good to go. I think by now you've noticed that these are 30 and this is 60. And the way we do that is we say this whole thing is 60 because 60 times 60 times 60, or 60 plus 60 plus 60 plus 60 plus 60 plus 60 is 360, right? All the way around. And there should be 6 triangles. Right? So the whole thing here is 60. Half of that is 30. So we know when the hypotenuse is 1. This is 30. And this is 60. This will be half the hypotenuse, and this will be that times root 3, so root 3 over 2. So notice that this right here is 8. So if we want to figure out the apothem, right, what we do is we multiply by root 3 to get that guy. 8 times root 3 will be the apothem. 8 root 3. And now we multiply them all together. 6 times 8 root 3 times 16 over 2. I'm going to do 16 divided by 2 and get 8. 8 times 8 times 6. 8 times 8 is 64. 64 times 6 is 60 times 6, which is 360. 6 times 4 is 240, so it's 384. That's what all these guys multiply to, and then we have a root 3 that we have to multiply by. So the area of our hexagon is 384 root 3. I'm going to leave 16 and 17. There's more examples. Same process, numbers are just a little bit harder. I'm going to go eat some lunch, and then I'll be back at 1 o'clock for regular geometry. See you soon. Ah, where'd my mouse go?